A very good evening to 12th standard students of St. John's. We are in 7th chapter, Differential Calculus and its applications. So far we have completed 4 exercises. And the last exercise is based on Rolle's theorem, Lagrange theorem, that is mean value theorem. Under the heading mean value theorem, we discussed and we studied 3 theorems statement. Using those statements, we did many problems. In this class, we will see some series expansions. Series expansions is our heading, out of which we are going to see 2 types of series. One is called Taylor's series, and the definition comes like this. Let f of x be a function infinitely differentiable at the point x equal to a. I repeat, f of x is a function infinitely differentiable, means it can be differentiable many times. We can differentiate it any number of times. That is the meaning of infinitely differentiable. At where? At the point x is equal to a. Then that f of x can be expanded as in this manner. So what is Taylor series condition? F of x should be a function which should be differentiable infinitely. Many times we can differentiate it at the particular point x is equal to a. Then that f of x can be expanded like this. What is the expansion? If you see, f of x is equal to f of a plus f dash of a by 1 factorial into x minus a plus f double dash of a by 2 factorial into x minus a whole square plus etc. So this function can be expanded like this if this function is differentiable many times at the point x is equal to a. That is called Taylor series. See the expansion. First one is f of a. What is the meaning? In place of x you put a, that is called f of a. What is f dash of a? First differentiate this, so you will get f dash of x. In that you put x is equal to a, that is called f dash of a. You know the meaning of 1 factorial. This is a factor, x minus a. Third term is f double dash of a by 2 factorial, which means we have to differentiate 2 times and then replace a in place of x by 2 factorial into x minus a whole square, plus it goes on like this. So this is called Taylor series. All the definitions that you should learn, because in 2 marks they will simply ask write Taylor series, even write Rolle's theorem, write a statement of Lagrange theorem, write the intermediate value theorem. So these are all 2 mark questions, so you should thorough with the statement of those things. So this is the statement of Taylor series. And then Maclaurin's series, which is nothing but the result that is obtained from Taylor series, is called as Maclaurin series. So we'll just read the formula. F of x is you just see this Taylor series. In place of a you put 0, you will get a Maclaurin series. That is f of x is equal to, in place of a just put 0, f of 0 plus f dash of 0 by 1 factorial into x, because a will become 0, plus f double dash of 0 by 2 factorial into x square, plus it goes on. So Maclaurin series is obtained from Taylor series by putting x is equal to 0. In place of a we are putting 0. So the formula comes like this. F of x equal to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus etc. So if they ask in 2 mark question, very simple answer. Just by writing this line you can easily score the 2 marks. So with this series expansion, we will go through few problems. Problem number 27. Write the Maclaurin series expansion of sin x. That is the question. So we have to expand sin x in terms of Maclaurin series. Again I repeat, write the Maclaurin series expansion of sin x. Whenever they are asking question like this, we have to minimum find 3 answers. 3 terms if you find, you can, because it is both Taylor series and Maclaurin series are infinite series. It will not end, it goes on. So how many terms that we are going to find when they ask in the examination means minimum 3 terms we have to find. So what is the function given? We will take that as f of x. F of x is equal to sin x. Since they are asking us to expand in Maclaurin series, you just see this formula. We need to find f of 0, f dash of 0, f double dash of 0, right? So since f of x is sin x, you try to find f of 0, which means x place 0. Sin 0, answer is 0. So if I get 0 as the answer, then if I substitute in this formula, the first term will become 0. So I have not found out any term up to this. We need minimum how many terms? 3 terms. So go for the next differentiation. F dash of x. Differentiation of sin x is cos x. Put 0 in place of x. So it becomes cos 0. Cos 0 is 1. Now a value we got here. So one value we got. Still 2 more values we need. So go for the next differentiation. F double dash of x. Differentiation of cos x is minus sin x. In place of x put 0. Sin 0 once again becomes 0. So in 3 out of these 3 things, 2 becomes 0. Only one answer we are getting here. So how many terms we found out so far? Only one term, because other 2 becomes 0. So we should not stop here. We should go for the next differentiation. So the next differentiation is f triple dash of x. Which one we have to differentiate? Minus sin x. Minus will be there. Sin x differentiation is cos x. Again put 0 in place of x. So it becomes cos 0, 1. Minus sign is present. So minus 1. So now we got 2 values. Still we need one more value. So go for the next differentiation. Differentiation of cos x is minus sin x. One more minus is present. So it becomes sin x. If we put 0, again the answer becomes 0. So still we have only 2 values. We need one more. Going for the fifth differentiation. F5 of x. Sin x differentiation is cos x. By putting 0, cos 0 is 1. So now we got 3 values. 1, 2. Before we have got 1 value. Since we got 3 value, we stop here and now we write the formula. The Maclaurin series expansion is f of x is equal to f of 0 plus f dash of 0 by 1 factorial into x plus f double dash of 0 by 2 factorial into x square plus it keeps on going. This is nothing but the Maclaurin series formula. The given function is sin x, so replace f of x by sin x. This value we found out as 0. F dash of 0 value is 1, so 1 by 1 factorial x. F double dash of 0 becomes 0, so this term fully becomes 0. What will be the next term? F triple dash of 0. The value is minus 1. So minus 1 by, this is 2 factorial means this will be 3 factorial. X square means here it will be x cube. What is F4 of 0? 0. So the next term also becoming 0. Fifth term F5 of 0 is 1. So 1 by 5 factorial into x power 5. Try to understand. This is x power 1. X power 2 becomes 0. So next one is x cube. X power 4 becomes 0. So next one is x power 5 plus goes on. So leave the 0. X by 1 factorial means x. 3 factorial means 6. So minus x cube by 6, right? 5 factorial means 1 into 2 into 3 into 4 into 5. When you multiply, 120 will be the answer. So x power 5 by 120, etc. So we need minimum 3 terms. That is why we found out so many differentiations. Since we got third value here, we stopped and written the formula and substituted. Hope you would have understood. Everything is based on the Maclaurin series formula. And they are asking us to expand in Maclaurin series. How many terms minimum we need to find? 3 terms we have to find. Question number 28. Write the Maclaurin series expansion of f of x is equal to tan inverse x. The x lies between minus 1 to plus 1. So the function is tan inverse x. Same thing. Here the function is sin x. Here it is tan inverse x. So first we are taking this as f of x. Putting 0 in place of x. So tan inverse 0. Answer is 0. So still we need to find 3 more value terms, because since the answer is 0 here, we need 3 more answers. So f dash of x, the differentiation of tan inverse x, we have studied in the first class when we started this chapter. Tan inverse x differentiation is 1 by 1 plus x square, right? So f dash of x answer is 1 by 1 plus x square. But what we are doing here is, by taking the denominator to numerator, it becomes 1 plus x square power minus 1. Hope you will understand. Because here the power is 1, it is taken to numerator, so the power becomes minus 1. Now, f dash of x is this actually. Now I am going to write one formula which we have studied in our previous classes. So I'll write the formula here. 1 plus x whole power minus 1. This we studied as a formula, and the formula says 1 minus x plus x square minus x cube plus it keeps on going. This is the formula that we have studied. In binomial theorem, many results we have studied. Out of this is one. Out of that, this is the result that we have gone through. So 1 plus x whole power minus 1. The expansion is 1 minus, since plus and minus goes in alternative symbols, 1 minus x plus x square minus x cube, like that it goes on. In the same way here, 1 plus x whole power minus 1. So use this formula. 1, in x place we are having x square. So 1 minus x means 1 minus x square plus x place x square. So x square means x power 4. Similarly, x power 3 means x power 6. Because in x place we are having x square. So instead of writing x cube, I should write x square whole cube. So it becomes x power 6 plus etc. So what we are doing after finding the first differentiation, we just taking this denominator to numerator and we are expanding that like this, so that the next differentiations will become easier. If I keep this and differentiate, I should go for differentiation formula 1 by x, then minus 1 by x square. Like that also we can do. It becomes little more difficult. But if we expand in a serious manner, then the differentiation becomes easier. Now, this is nothing but f dash of, we found out f dash of x here itself. But what we did, taking this to numerator and expanding this using the formula, we got f dash of x. We have simplified f dash of x like this. Now put in place of x 0. So all the other terms from the second term, everything will become 0 because x comes. If I put 0, everything goes off. Only 1 remains. Hope you will understand. So f dash of 0, I got one value. Still 2 more values I need. So I am going for the next differentiation, f double dash of x. So if I differentiate 1, it becomes 0. X square differentiation is 2x with minus 2x. X power 4 differentiation, 4x cube. This is 6x power 5 with that minus sign plus etc. Now I am applying 0 in place of x, f double dash of 0. Since here itself x, putting 0, everything will become 0. So out of 3 values, this becomes 0, this also became 0. Only one answer we got. How many answers still we need to get? 2 more answers. So what is the next step? F triple dash of x, third differentiation I have to go. Can you tell what is the answer? This becomes minus 2 because differentiation of x is 1. This becomes minus 2. This becomes what? 3 into 4, 12x square. Similarly here 30x power 4 plus etc. That is what I am going to write in the next line. I repeat once again, minus 2 plus 12x square minus 30x power 4. So what I said that I have written here, f triple dash of x is this, minus 2 plus 12x power 2 minus 30x power 4 plus etc. Replacing x by 0. From the second term everything will become 0, only minus 2 remains. So we got a value here. So 2 values now we got. We need one more. So going for the next differentiation. f4 of x means fourth differentiation we are doing, which means we need to differentiate the third one. Minus 2 becomes 0. Here the power comes front. 24x power comes front. 4 into 31, 20x power 3 plus etc. Putting x as 0, everything will become 0 because x is present in each and every term. Totally it becomes 0. Again going for the fifth differentiation. 24x, the answer is 24. If we differentiate this, 3 into 120, 360x square plus etc. Putting 0. From the second term everything becomes 0. One answer we are getting here, 24 is the answer. So from this up to this, now we got 3 values. So I am happy that I have got 3 values. So I will write the formula. This is the Maclaurin series formula. F of 0, answer is 0. F dash of 0 means 1. So 1 by 1 factorial x. F double dash of 0 is 0. So this term fully becomes 0. F triple dash of 0, answer is minus 2. So minus 2 by 3 factorial x cube. F4 of 0 is 0. So and that term will fully become 0. Plus F5 of 0 is 24. So 24 by 5 factorial x power 5. Hope you will understand why I am writing x power 5. Because x, this is x square term 0. Here it is x cube. X power 4 term 0. So x power 5 comes here. So finally the answer is tan inverse x is equal to, we will leave 0 and all, x by 1 factorial x. You just try to understand, 3 factorial means 1 into 2 into 3, 2 will get cancelled, 3 alone remains, so minus x cube by 3. And here if you see 24, the simplification is given here, 24 by 5 factorial means 1, 2, 3, 4, 5. 2 3s are 6, 6 4s are 24, right? 2 3s are 6, 6 4s are 20. So these 3 will get cancelled, this 24, only 5 remains in the denominator. So that's what is written here, 5. So it becomes plus x power 5 by only 5, not 5 factorial, because 1, 2, 2, 3, 4 gets cancelled with this 24, only 5 remains, minus etc. So this is the expansion for tan inverse x using Maclaurin series. Hope you will understand this. Everything is based on Maclaurin series formula. How many terms that we need to write? Minimum 3 terms. Sum number 29. Write down the Taylor series expansion of the function log x. The function is log x about x is equal to 1. So about this point we have to write this function in Taylor series. They have given up to 3 non-zero terms. They are asking us to write 3 terms for x is positive. So what we have to do? We should write log x in Taylor series expansion. About which point x is equal to 1. How many terms we have to write? 3 terms. So what is a given function? Log x. What is a given point? X is equal to 1. Keep those 2 things in your mind. We'll see the answer now. So the given function is taken as f of x. F of x is equal to log x, right? The point is given as 1. So x is equal to 1. So we are mentioning the point as a. A is 1. What is the difference between Maclaurin series and Taylor series? Taylor series formula is f of a by f of a plus f dash of a by 1 factorial into x minus a. Like that the formula goes on. If you don't know the formula, you just see this line. F of a plus f dash of a by 1 factorial x minus a. Like that it goes on. What is a? The value at which point we are calculating, that is called a. So here a is 1. So we need to find f of 1. F of a. A means 1. In place of x you should substitute a. A is 1, so we are substituting in place of x 1. So log 1 value is 0. Go for first differentiation, f dash of x. Log x differentiation is 1 by x. Implies substitute the value 1. Maclaurin series means we will substitute 0. Taylor series means they will be given the point. That point we have to take and substitute. A is 1, so f dash of 1 you put, in place of x you put 1, 1 by 1 becomes 1. Go for the next differentiation, f double dash of x. Differentiation of 1 by x, we should know this as a formula. 1 by x differentiation is minus 1 by x square. Substitute 1, so minus 1 by 1 minus 1. Go for, now 2 values we got, we want one more value, so next differentiation. The differentiation, I'll write the answer here. The differentiation of 1 by x square, the answer is minus 2 by x cube. Differentiation of 1 by x square is minus 2 by x cube. But one more minus we are having, so minus and minus will become plus. So we are writing plus 2 by x cube. Compare this. Differentiation of 1 by x square, minus sign comes. So minus and minus plus, so 2 by x cube. Replace x by 1, so answer is 2. Since we got 3 values, we will write the formula. The Taylor series is, this is called the Taylor series. The function given is log x. F of a means here f of 1. F of 1 is 0, so first term becomes 0. F dash of 1 is 1, so 1 by 1 factorial x minus a is 1. F double dash of a, f double dash of 1 is minus 1, so minus 1 by 2 factorial x minus 1 whole square, plus what will be the next term? F triple dash of a, here f triple dash of 1 is 2, so 2 by 3 factorial x minus 1 whole cube plus etc. So simplifying, log x is equal to, leaving this 1 by 1 is 1, so x minus 1 plus into minus minus, so minus of x minus 1 whole square, 2 factorial, answer is 2, plus 3 factorial means 1, 2, 3, 2 cancel, 3 alone remains, so x minus 1 whole cube by 3 minus etc. They are asking us to write 3 terms, so we found out 3 terms. Again, these are all same type of problems. First 2 problems we saw using Maclaurin series, the third we are doing it in Taylor series. What is the difference? Maclaurin series means we'll put 0. Taylor series means the point they will be giving, that point we have to substitute and find out. Problem number 30. Expand sin x in ascending powers of x minus pi by 4 up to 3 non-zero terms. So this sum and the previous this sum are almost same problem. They have clearly, in this sum they have clearly given Taylor's series expansion. Here they have not mentioned the name, but by seeing the question itself we should know that this can be done only by Taylor's theorem, because ascending powers of x minus pi by 4, this is the clue for us. If I equate this to 0, what happens? X is equal to pi by 4 will come, so x equal to a. Here a value is 1, no, similarly here a value is pi by 4. So once we got a value, that will come in Taylor's series expansion. What is the given function? Sin x. We should expand sin x in Taylor series up to 3 terms, where a is pi by 4. That is the meaning of the question. We will see the answer now. Now see, what is the given function? Sin x. So that is taken as f of x. Here the a value is pi by 4. That we have to identify from the question. A is equal to pi by 4. F of x is sin x. So we have to find f of a, which means f of pi by 4. Sin pi by 4, answer is 1 by root 2, sin 45 degree. Go for the first differentiation, f dash of x. Sin x differentiation is cos x. Substitute, in place of x you substitute pi by 4, so that is f dash of pi by 4 cos 45, that is also 1 by root 2. Second differentiation. Now we got 2 answers, we need one more answer, so we are differentiating second time. Cos x differentiation, minus sin x. Substitute in place of x pi by 4, minus sin 45 degree, minus 1 by root 2. So we got 3 values straight away. So we'll stop the differentiation here and write the formula. The Taylor series is, this is the formula. Given function is sin x. F of a, if you see the value, 1 by root 2, plus f dash of a is also 1 by root 2. So 1 by root 2 by 1 factorial x minus a, x minus pi by 4, plus what is f double dash of a? Minus 1 by root 2. So minus 1 by root 2 by 2 factorial x minus a whole square. A is pi by 4. If you go through the formula first and written the formula and memorized it, means you will easily understand these steps. So 1 by root 2 plus, simplifying this, 1 by root 2 x minus pi by 4. This is 2 factorial means 2. That is also denominator, this is also denominator, so they will get multiplied. It becomes 2 root 2. Minus sign will combine with this, becomes entirely minus 1 by 2 root 2 x minus pi by 4 whole square plus etc. Again they are asking us to write 3 terms. We written 3 terms, so we can put dot dot dot. So this is the answer. Question number 31. Expand f of x is equal to this function in powers of x minus 1. Again, if you see the first problem, they have clearly given expand using Taylor's theorem. But even in this sum, they have not mentioned Taylor's series. Here also they have not mentioned Taylor's series. but we have to identify that it can be done using Taylor series. How means, the function is given, they are asking us to expand this in powers of x minus 1. So this is the important clue for us. If I put equal to 0, x becomes 1. So that 1 should be taken as a. So whenever a comes, we will go for Taylor series. So that is how I am finding out I should expand this using Taylor series. So the given function is taken as f of x. A value is nothing but 1. Suppose if it is given x plus 1, then a value is minus 1. Keep that in mind. X minus 1 means a value is plus 1. Now what I have to do, after writing f of x, I have to find f of a. A is 1, so find out f of 1. 1 plus 2, 3, 3 minus 3, 0. So f of 1 value is 0. Go for next differentiation, f dash of x. X square differentiation is 2x. Minus 3x means minus 3. 2 constant becomes 0. So differentiation of this is 2x minus 3. Find out f dash of 1. So substitute 1. 2 into 1, 2. 2 minus 3 is minus 1. Now we got one value. Go for the next differentiation, f double dash of x. 2x differentiation is 2. Minus 3 becomes 0, constant. So since only 2 is having, we cannot substitute anything here. Even if I substitute in place of x1, the answer will be 2 only, because no x there, no x here to substitute. So f double dash of 1 is also equal to 2. Now I cannot go for the next differentiation, right? Because next differentiation becomes 0. Since this is constant, the next differentiation is not possible. So we will stop here and write the formula. The Taylor series is the function. Here no, I have not written the formula. Directly I have written the answer. F of x is equal to f of a. F of a is 0. So 0 plus f dash of a minus 1. So minus 1 by 1 factorial x minus a plus f double dash of a 2. So 2 by 2 factorial x minus a whole square. Here I cannot put plus dot because the next differentiation becomes 0. So totally only these will present. There will not be any other terms here. So I am not putting dot dot dot. So simplifying this, this is nothing but only minus stays, minus x minus 1 plus 2 gets cancelled, x minus 1 whole square is the final answer. Hope you will understand. Now we'll go to some theory part. Listen carefully. Using that we'll try to do some problems. Indeterminate forms. So this is the heading, indeterminate forms. Indeterminate forms. We will see few models which are called indeterminate forms. 0 by 0, which are all things we don't have proper answer. They are called indeterminate forms. Infinity by infinity, 0 into infinity, infinity minus infinity, 1 power infinity, 0 power 0, infinity power 0. All these things we will struggle to find the exact value, right? These things we cannot exactly say what is the value. So that type of forms are called indeterminate forms. We cannot determine the exact value, so it is called indeterminate forms. Now we see one rule called L'Hopital rule. The name of the rule is L'Hopital rule. We will clearly see what it is. Using this only we are going to do the next exercise problems. I'll read out, listen carefully. Suppose f of x and g of x are differentiable functions. What is the meaning? We have two functions, f of x and g of x. Both are differentiable functions. The meaning is we can differentiate both the functions. That is the meaning. And if g dash of x not equal to 0, suppose I am differentiating g of x, it becomes g dash of x. The value should not be equal to 0. If these conditions are satisfied with one more condition, limit x goes to a, f of x equal to 0, and limit x goes to a, g of x equal to 0. Again I repeat, f of x and g of x are two differentiable functions, which means we can differentiate them, and g dash of x, the differentiation of this should not be 0, and if these two are there, that is limit when this x goes to a, this function should become 0. At the same point, that is when x goes to a, the other function should also become 0. Then if these are all the things that we have, then this L'Hopital rule gives us limit x goes to a f of x by g of x, right? What happens for limit x goes to a f of x? It becomes 0. What happens for g of x when x goes to a? It becomes 0. So this also becomes 0. This is also becoming 0 when x goes to a. So we will have 0 by 0 format, right? Indeterminate form. So that can be replaced by, that is equal to, same limit x goes to a f dash of x by g dash of x. So what is L'Hopital rule? When we have limit x goes to a f of x by g of x in indeterminate form, suppose if this is also becoming 0 and this is also becoming 0, either this becomes infinity and this also becomes infinity. So when we get indeterminate form in this type, that can be replaced by this one. This can be replaced by this, that is limit x goes to a, differentiate the numerator separately, differentiate the denominator separately, and apply the same limit. Then this and this will give the same answer. So what L'Hopital rule gives us the guarantee? L'Hopital rule gives the guarantee that when we have an indeterminate form, when applying the limit, when we have indeterminate forms, that is 0 by 0 or infinity by infinity, any indeterminate forms, that can be replaced by another limit where limit x, same limit does not vary. X goes to a means here also x goes to a. What we have to do? Differentiate the numerator separately, differentiate the denominator separately, then apply the same limit. That is what L'Hopital rule says. One more time I am going to repeat. F of x and g of x are two differentiable functions. When we differentiate g of x, it should not become 0. Suppose when x goes to a, both the functions becomes 0. Then if we calculate, this becomes 0 by 0, right? Then that has another answer. We can calculate this using another method. What is the method? Limit, same limit, differentiate numerator separately, differentiate denominator separately, then apply the same limit. You can even calculate this answer using this. That is called L'Hopital rule. The next thing, composite function theorem. What this theorem says is limit x goes to a log f of x can be written as log can be taken outside and limit can be taken inside, and we can write like this. This is called composite function theorem. Can I repeat? Limit x goes to a log f of x can be written as log can be taken outside, limit can be taken inside, which is called composite function theorem. We will stop up to this, continuing the problem in the next video.